Yep, we will certainly be talking APIs and the different technologies that we can use to deliver APIs because it has been growing quite a bit in the last 5 or 6 years. So, hi everybody. Let me start by introducing what I'm going to be talking about. So yes, APIs, and give you just a little bit of background about me and about my role and my work with APIs very briefly. Then we're going to look at the basis of the 3 core API technologies that we're comparing and sort of trying to decide which way to go and how to go there and when to go that way, so that we've got some foundation that will inform the sort of pros and cons and the recommendations that ultimately we'll arrive at. So let me start with a little bit of an introduction. So me and Five, yep, father, husband, blogger, author. Although the order of those depends on who you talk to. My wife would say I'm an author, blogger, father, then the husband. But that's life, and I'm sure others will experience something similar. I am a technical architect by background and tech evangelist for Capgemini. And I work for Capgemini here in the UK as part of the Oracle delivery unit. So we specialize in Oracle technology, but not exclusively Oracle. I'm very fortunate to have won a number of awards with the team, or the team have won a number of awards in which I am part. And you know, very proud of what we've managed to achieve with what we have as a team. But we do also work with a lot of open source technologies. And probably the only thing that you need to know for the rest of this session is my domain name, MP3 Monster. And I'm not going to try and explain now why it's that. There is an explanation on the site if you want to chuckle. But everything that is in this deck is accessible through that site, so hopefully you can follow me along and not worry about trying to grab screens or anything like that. In addition, I also run a developer meetup in London, along with the sponsorship from Oracle. Lucas probably mentioned that he does one as well. And we focus on all things middleware, modern cloud apps, infrastructure as code stuff. And we get a blend of external speakers, myself, Oracle product management, when we can co-opt them to come and talk. And we have a pretty relaxed evening, a bit of pizza courtesy of Oracle and some beers, talk technology for a couple of hours and have a chuckle. And if we're flying the drone that we have, we normally end up having a laugh at some of these expenses, they crash it. So that's the meetup. And then of course, I've written for various books and magazines, and these are the latest efforts, with Fluent D being the latest one that's in development at the moment. That's Capgemini. I won't bore you with any more. If you want to know more about Cap, then reach out to me. I can talk to you about it and put you in contact with the right people. So let's start and understand a little bit about the API revolution. So perhaps in chat, who thinks they know when the first APIs came about? Does anybody want to try and guess? I'm assuming everybody's nice and caffeinated now, so can throw us some suggestions. Just give it a moment, see if we see anything. 1960s, yeah, not bad estimate. Okay, so let me move on. Oh yes, before I talk about the timeline, let's talk about what an API is. So I went back to Wikipedia because APIs to many people mean many things. And for me, an API, because I'm old enough, was actually a programming construct. You know, in Ada and Java, you've got the JavaX packages, and the interfaces are your API. But many people today, you say API and they'll think REST. So I just went back to Wikipedia and said, well, what's the foundation for the idea? And do you know what the key messages are? It's about communication and communication protocols, but not any specific protocol. Doesn't prescribe HTTP, doesn't prescribe FTP, doesn't prescribe RMI or any of the others that we might know. It's a facilitator or tool for building software, which is where my original definition comes from. It's important because it's a communications definition between different software components. Now, today we do that through networks, but 10, 20, 30, or back in the 1960s, we did that either by a file or by direct code and had monolithic applications. Okay, so that's an API, but what's a web API, which is where the technologies we're looking at are involved? Well, definition for that is an API. Well, yeah, wow, that's amazing. But the only other two key points in there is it relates to web servers and the web browser. So it has some sort of TCP and probably HTTP based context to it, but that's it. Back to that question. 1962, I think, is when they formalized the FTP standard, which is effectively where we could start talking about APIs, because it is FTP is the technical part of a point of contact contract. You could argue that databases and database tables are a form of API, insofar as there is a definition in your definition, your DDL, and you've got rules about who can and can't access those tables to put data in and out through that exchange. As we move into the 70s and 80s, we've got NFS, and these are all very much around shared storage technologies. And then into the early 80s, we had a flurry where we switched over to networks with COM, DCOM, CORBA, RMI as technologies. Now they all use networks typically on the TCP or UDP layer, and they were very much language driven and technical, so they were effectively serializations of objects, and you couldn't understand them unless you had code to interpret the actual payload. And then we suddenly swung towards the idea of actually, do you know what, we need to be able to see what these payloads are, and they need to be easier to work with. And we saw XML RPC first, and then, believe it or not, in rapid succession, SOAP and REST. The definitions actually originated within a year or two of each other, although for a long time, SOAP, WSDL, and the standards-driven model for APIs was the way things went, and then people started to get to the point of the standards are just so complicated, it's difficult, if not impossible, to work with. And of course, they started to get overlap and contradict occasionally, and it got unwieldy, to say the least. Then moving on, more recently, we've seen the rise of the other two that we're going to talk about today, gRPC or Google RPC, although the G does change in its meaning from time to time, depending on who you talk to. And perhaps less known, but is part of the landscape, is Avro. Avro is a way of structuring the messages particularly used around Kafka-based interfacing. And then GraphQL, which sits in the human readable domain and is an evolution, if you like, of REST. And bringing some of the old SOAP and WSDL ideas back. So yeah, 1960 is pretty good. So let's look at the evolution and why gRPC and GraphQL are of particular interest, because there are other ways of doing APIs. So I went back to Google Stats and looked to see how well these two terms were trending. And you can see around about 2016, 2017, the two technologies start to really pick up momentum. gRPC is perhaps not picked up so much until more recently, because we are starting to see more of its use within the microservice ecospace, but GraphQL has really taken off. And when we talk about GraphQL, you'll see why. And then put that into context of REST, because many have claimed that, you know, GraphQL and gRPC are candidate REST killers. You can see from that trend that whilst there's a tiny drop from the peak there, they're certainly not impacting. And why not? Well, we're just seeing greater growth in API use every day. And whilst REST may have ceded a little bit, purely because some other technologies are a better fit now, and they're maturing to the point where there's the resources for people to adopt alternate models, we're just seeing more API adoption, and therefore the total workloads that are API based has grown. So let me talk about REST. We all think we know it, but you'll be surprised actually, and it even surprised me. I've been working with REST APIs for quite a long time now. But if you go back to the foundations, there's a few things that people tend to forget, because we focus on the idea of JSON and HTTP. So the original concept of REST came out in 2000 as a result of a paper by a guy called Roy Fielding. And he expressed it as state transfer representation. And depending on the paper or article that you read, they'll pick out somewhere between 6 and 8 key points from his paper. And I've gone for the slightly larger number, because it allows me to pick out a couple of little nuances. Uniformed interface, that's effectively the URI based element of it that we all know well. But he also identified something that we don't use very often, and that's HateOS, which is the ability for APIs to reference other APIs so that you can use it as a traversal through a data model, if you like, or traverse through services. Resource manipulation through representation, so that's effectively using the HTTP create, update, delete concepts, you know, patch, and a few others, because there are more than put, post, get, delete, you know, patch, head, and others are there as well with specific uses. Client server, well, that's kind of a no-brainer really. Stateless, the idea that you don't have to know previous API calls or interactions to know the correct actual state. Sometimes people get suckered into the I'm just going to communicate a bit of the information, and you need to have known prior conversational state to know the true story. But the original idea is that you don't have to do that. The message will carry all the stateful information or state information. Code on demand is an interesting one because in the original paper, he posited the idea that within a REST call, you could actually pass your JavaScript through. So if you want to pass not just the data, but also some logic, you could pass that in the RESTful call. It's a bit of an unusual one, and I don't think I've ever actually seen it used. But it was there, always there. Layered. This is one that people sometimes get tripped up on. People, particularly if they're used to working with older models, particularly FTP or database, shared database tables as ways of integrating, they tend to think that a REST API can take megabytes and terabytes of data in a single call, and it can't, and you should be aware of the fact, because what is in the network between you and a client is the idea that there's going to be firewalls, network routing elements and things like that that you know nothing about. And you don't need to know about anything in the network or beyond it. All right, you should try and avoid that. It should all be handled through the way we define our API. So, you know, never design an API such that your payloads are so big that you're going to get timeouts, or a network device is going to say this payload's too big. Cacheable relates to the layering ideas to an extent, particularly at the network layer, that between you and the provider of the API endpoint are potentially caching locations, and therefore you need to be able to tell the network components indirectly whether the data is safe to be cached or not, whether it's going to have a problem with caching, so that they won't cache the data. If you're dealing with PII, that's the personal information, then you probably don't want infrastructure caching that data because it's sensitive. Yeah, and if you're providing an API for getting and updating personal details, then you probably don't want it caching either, because you want it to reflect the latest state as you retrieve the data, update it, and verify the change. And then, of course, it's self-describing. That most people tend to treat as it's humanly readable, but it should be a bit more than that. You know, attribute names in payload should be understandable and meaningful. So, as a quick summary, yeah, as I mentioned, there's all the verbs, the get, post, put, delete. There are header attributes that we can make use of, many of which we don't make as good use of as perhaps we could do. There's some great ones in there around get content sense and things like that that would help an API semantics greatly. Then there's the question of versioning. How do you deal with changes to APIs? In Roy's original paper, he suggested that you don't need to deal with that, which is quite interesting. Raises some interesting questions about how does change work. Then we have the Richardson maturity model that was developed in I think it was the mid-80s, where we defined a number of levels of maturity. And some people have been saying perhaps we should change the maturity model now, because most people are at least level 1, if not level 2. And then we've got the IETF standards and your own development standards and security practices in how you build your URIs and payloads. So what are the benefits of REST? Well, we all have a good handle on it. It uses HTTP1, not HTTP2, so that just means just about any application server will support you. URIs will work in such a way that it makes it easy to exploit caching if you want to cache, use content delivery networks, use the browser or reverse proxies. Self-describing. Yep. If we're good about how we define our interface. Cons, it is actually very, very flexible because there are no real rules enforced. So you can do some really bad stuff like putting SQL in a URI, which is pretty dangerous stuff in terms of what it could do downstream. You can get away with no documentation at all. Your approach to versioning may not exist. Therefore, you break your consumer's use of your APIs. We can be too terse with the data. That's to say, when you make a request for data, you give the bare minimum. As a result, a client application has to make lots and lots of API calls to get a data set that it needs. Or you go the other way, you can be too verbose, and you end up shipping megabytes of data when a mobile application only actually wanted a couple of K. And then, of course, there's questions about overheads, the communication and conversion to and from strings, because everything is stringed to be humanly readable, and compression. You know, the only compression that's in play in a REST API is what HTTP provides us with, or HTTP1 provides us with, to be exact. Okay, so let's now jump into GraphQL. This is a relatively new upstart, led by Facebook. And it comes to that verbosity, terseness problem that got them going with GraphQL. What they were finding is most Facebook users use their apps rather than a desktop web interface. And as a result, the app was being incredibly chatty, constantly back and forth, asking for more data and more data and more data. And it meant the back end was struggling to cope with that demand quickly enough, particularly at the first point of contact, where it would then take the request and route it out to the right parts of the back end infrastructure. So they started developing the idea of GraphQL, which actually works in simple terms, and we'll see a fragment in a minute, around the idea of, I can tell you what I want now. You tell me what's available and I'll tell you what I need and want. And therefore it kills the verbosity because I get the data that I need and only get it in a single request. Hugely more efficient, a lot easier to work with, and more flexible. And Facebook open sourced it, and then it's now under the governance of the Linux Foundation, just like CNCF works under the Linux Foundation. So its roadmap and journey forward is completely independent of Facebook. But obviously they have a lot of people involved in committing and developing the open source version of it. But it's since been adopted by a lot of big players, GitHub, Yelp, Twitter, Instagram, just to name a few, and highly successful in those adoptions. Great for us because it still uses HTTP. It's based on JSON, the payloads, the request and the response. So very easy to understand. If you've done your bit of REST, then getting to GraphQL is not a difficult climb. It starts to address some of the common challenges around REST with versioning and pagination and things like that by explicitly setting ways of handling that. So there are, within the definition of the standard, because GraphQL is a standard, are guidelines on how do you version, how do you deal with lots of data through pagination, how do you express pagination, and so on. I know it's a lot of people, when they first hear about GraphQL, think of graph databases. There isn't any relationship other than the fact that some mathematical concepts of graphing are involved in the most abstract thinking in this area. So yeah, don't worry about graph databases. So here we go. Let's just look at how it builds. So we start at the top here on the top left. We have type structures and payload definitions now. In REST, you don't have to, although you overcome this typically by using API Blueprint or OpenAPI or Swagger definitions. But in GraphQL, you need this because what you're going to be doing is saying, I want these attributes in the request. Yeah, so you define the entities and the objects and the payloads, and you go from there. Then within the type definition, you've got the operations, and there's very little difference between a query and a mutation. A query is just effectively the retrieval of data, and the mutation, it reflects the create, update, delete operations. And what we do is we send in a query. As you can see here, the query is using the types at the top that I've doctored from the SOAP API. That's the Star Wars API that's out there for the geeks like myself, where I can go and do a query and say, I want to know about Droid with the ID of 2000, and I'm interested in knowing that droid's name and its primary function. Well, as it happens, Droid 2000 is C3PO for the Star Wars fans, and of course that means he's an interpreter. And that's basically how a query works, as simple as that. The backend gives you the data based on what you've asked for. Yeah. And you can then ask and cross multiple domains, and the back end of a GraphQL structure will actually merge the data for you. So here's an example of that, where I've got two related entities that have a common reference point, and I'm asking for the same droid now, but I'm asking for the name, and I want to know the name of the film that droid appears in, or name of the films. So you can see I've got the name C3PO, and then I've got a nested structure containing the films. And I've only put 2 in just to be lazy and make it readable. But essentially you can see at the top in the square brackets, I'm referencing another structure, and I'm declaring whether it is relating to one or more entities. So the square brackets is the multiplicity, whether it's more than one response. The bang you can see in the type definitions means it's mandatory or not. And then you can even go as far as saying that certain values are actually computed and calculated for you on the fly, and how to calculate it. So has friends is calculated by looking at the value on the for friends. So that's the friends entry, and if it's not null, then that must be a true. Yeah, if I have friends, a list of friends, then I return Boolean true. So how's it realized? You provide a domain, a URI, a single URI here, unlike a REST endpoint where you put the attributes that you might be after or in a query, and you use the path to normally express an ID for the entity that you're looking for. You have the entity name. Here you just have a single endpoint, and then inside the payload, inside of the post, you describe what you're requesting. And that request then gets processed by the back end to pass it to what's called resolvers, which is little bits of logic that then work out and get the data, and then it can merge the data sets together. There are some standard frameworks, some are open source, some are licensed, but you can go download those and they give you the skeleton to get started. Right, so what are the pros? I can now describe what I want when I want it. Yeah. The workload of bringing data sets together can be done in the back end, making it really easy for the front end to be lightweight and not having to work too hard. We've got good, strong data typing, so there's no confusion about when I say this is a date, do I mean that's a date represented as a string, or is that date represented as a numeric code or epoch, and so on. Payload is JSON based, so it's really easy for us to understand and addresses some of the common problems that APIs can suffer from. The downside, we can't fully leverage HTTP because your URI is going to be the same for every request. Your caching can't work using the URL. Bit of a downside because it means the backend will have to work harder and service all the requests unless you've got something in the middle that's a bit smarter and finds another way of solving the cache requirement. Yeah. Notifications mechanisms are closer to relational object persistence. What we're driving towards here is it's very easy to go and create a GraphQL schema that represents your database structure. Now, that's really quite dangerous because if you want to change your database structure because, say, you're going from a SQL to a NoSQL to change the way things work, or you want to change the relational schema to make it more performant, there is a risk of that propagating back into your REST API, your GraphQL API. And if it's a disrupting change, that affects your consumers, making your end-to-end very brittle. So it's important that you, if you use GraphQL, to not look at your persistence layer when trying to work out your schemas. Think about the services and entities and relationships that are needed for your client. All right, so that's GraphQL. Now gRPC or Google RPC. This takes us more back towards, in many respects, the days of Corba. It is not humanly readable because it gets compressed. I mentioned the G changing. It is open source. It's heavily adopted by quite a few people. Netflix use it between their microservices when they're doing direct calls. If you look at a lot of the Google services as well, you'll see the REST APIs they offer typically map straight onto a gRPC API. And I believe Maps, for example, you can actually call gRPC directly. You don't have to use a REST API. It is a lot more technical. You talk about services and messages rather than objects. It is lightweight, it is compact, it will work nicely on small devices, which makes it great for potentially IoT use cases. Still works over HTTP, but relies on HTTP2. It's layered, so it allows it to change. The payload is implementation agnostic still, but it is compacted and it's binary in nature. It has a whole bunch of standardized error management messages, making another classic REST API problem slightly easier by characterizing some of the issues. The characteristic that makes it a lot more like Corba is the fact that you have a meta language called protobuf, which you describe the services and the payload again, and it has some rules like GraphQL about how you extend and evolve them, and then you have to compile it into your languages, which is what a Corba IDL always did, is you took the IDL, which described the interface, and then you compiled it into your component, and it gave you the Java or C code that you needed to integrate it into the rest of the application. That's exactly what gRPC is doing, but it's a lot more pervasive in the number of languages supported, from C and C# to Objective, to Go, Node, Dart, which is one of the newer languages that are coming around, and of course our trusty favorites. Yeah, uses HTTP2 because it's exploiting some of the semantics and wire level protocols that are in there to get the compression and performance. So this is what it looks like. There are two syntaxes, Proto2 and Proto3. This is protobuf, is it to use its full name, and there's not full compatibility between Proto2 and Proto3. So I've tended to focus on Proto3, which is the newer one, obviously. And basically you can see here, you define a message, and note how the data types are a lot more stringent. You know, we're talking about an unsigned integer of 32 bits in the message ID, which is a lot more strict in its definition. And then you can see we've got strings. We declare whether elements are repeated or not, and you're advised to put the repeating blocks in later in your definition, because of the way it compresses it. Means that the repeating segments being later, it can do a lot more stuff efficiently. And then what you do is you create a service, and the service defines a set of methods. You know, this time we're saying it's an RPC, and I've got the same again as my GraphQL. I'm asking for a droid, and I'm asking it by its ID, and it returns an object of droid, and it tells me what the structure is for that droid in the type definition in the protobuf. Okay. Compile it, you run it through a code generator, and you can give the code generator some clues in the protobuf file. So things like, what's the package name, using generics and things like that. Do you want it divided across multiple files or not? That's useful if you've got multiple objects being defined, because do you want it in inner classes or not, or separate, completely separate classes for it. Okay, so we give that, and then what it does is the proto compiler that generates the Java code, and you will get something like this down here. And if you look carefully, you will see there are methods to take and handle the services. As you can see, I've got get descriptor, get character by ID just above my arrow, line 162, if you can read that, which maps directly back to where I was. Pros, I think I'm pretty much covered. So, you know, the code generation gives it the performance and things like that. Compression means it's great for shifting across networks, multiple languages, so on. The downside is a lot more technical. You can't look at the messages and read them. There are, you know, requires HTTP2, and then you've got the protobuf versions and things like that. Right. So I've kind of explained or summarized the three technologies, some of which you've probably gone, yeah, and so what, Phil, I already knew that. And some of it you hopefully have gone, that's interesting. So which one do I use? That's the fundamental question. Well, actually, the bottom line is if your API is really good and people want to use it, then the technology really won't matter. If your API is doing something that people need, they will work it out. If you're competing and offering an API that someone else is also offering, and you only provide one technology, then you might have a bit more of a challenge, because obviously it's about how easy is it to consume. So to come at it, I've tried to identify the characteristics of good APIs, and actually a lot of this is technology agnostic, but these are all the features. If you provide all of these, then the odds are you've won the argument regardless of the technology. Yeah, but not many people do, and in a non-public API, you certainly won't be given the bandwidth to address all of this. You know, if you go and look at Google's APIs or other big providers, they've done this and done this well because it's their bread and butter. Therefore, they will win. A lot of people just do not have the bandwidth or the budget to necessarily do it, or are not looking for the same level of benefit. Another way to look at it is to compare the different technologies against Roy Fielding's criteria, but immediately biases the answer to REST, because if you look at the core criteria or core goals that he set out, of course REST is going to answer them. GraphQL answers some but not all, and gRPC is definitely disadvantaged. So an interesting way of doing it, but actually probably quite unfair. Another way is to actually look at where it fits well, and this is where the approach that we take and advise people. RESTful is good for public end use. It's because it's well known, it's well understood, it doesn't create a large learning curve. Its technology demand is very low, it's very flexible. You got the additional ability to do things such as building webhooks on top of REST for handling asynchronous use cases and things like that. If you're using a COTS or off-the-shelf solution within an organization, it's great as well for that, because just about any product that's been built in the last 10 years is going to at least have support REST to some degree. GraphQL, well, is very Genesis, points to the public use. It's still relatively easy to get to grips with, plenty of toolkitting to support you. It does also support streaming as well. So getting multiple events out to consumers is there. Internal APIs, some solutions are starting to offer you GraphQL as well, but not many today. Fantastic if you want to expose your data warehouse, data lakes, bulk data input storage in a simple way, because you can say, look, here is all the data that, and then you can let them choose, the consumer choose the data to be used. Which is hugely freeing up. You will not get millions of requests saying, can I have an API with these particular attributes? Can I have an API with those particular attributes? Or having to evolve a standard REST API. And then into gRPC. Great if you have both control of both the consumer and the provider. That's critical. To be really successful with it, if you've got control of both ends, that's great, because a change in the API is a code impacting change, because you're doing that proto compiler from the IDL to code. All right, bandwidth sensitive environments, fantastic as well, because it does a lot of binary compression in the data transfer. So that really helps. It makes it very efficient and quick, which is where it's pretty useful within microservice estates as well. And then if you've got microservice to microservice direct calls, and and own both microservices, you've just use the microservice technologies to allow you to scale and things like that, then fantastic, it solves that problem as well, works well there. Good for streaming and bidirectional data flows because of the way it works, and tiny footprint, so IoT devices, because it's all compiled down into the code base. You don't have to have an app server running to contain part of the functionality. So that's our recommendations. So the important thing here is SOA historically, and products like SOA Suite historically tended to get used as I have one hammer and this solves all my problems when it comes to integration. And we really best not going down that route. So choose the right technology for the right use case. Yes, REST is very flexible, but it has its limitations in it can be misused. The others are more opinionated, which makes it easier not to make mistakes, but then those opinionated positions have to be suitable to your use case. Yeah, so there is no one silver bullet, and we're always better off having a kit bag of answers. And that's really the underlying idea of polyglot in the world of microservices. So let's see if we got some questions. If I just pull up the Q&A. Right. Okay. Would I say it's worth supporting 2 or more kinds of API in the product these days? Yeah, my inclination is yes, if there's a clear case. I'm working on a program at the moment where we're probably going to use GraphQL for surfacing data because we've got a fairly large data repository, but a smaller set of data will be subject to change, and there's going to be fine-grained access control on the change. So we're likely to do the data change through more traditional REST interfaces, because trying to express the access controls when trying to do an update through GraphQL, for example, is going to be very difficult, very confusing for the users. And I've got to work with end users that I do not know at the moment. And Dana asked, how can I edit the data in this report? And sorry, I missed the context to that one. Are you able to put a little bit of elaboration to that?
I think that was from the last one.
All right, okay, smashing.
No worries.
Any others? Otherwise, I will, I think we're pretty much bang on time. I will step back and let the next presenter take over.
We are perfect on time. Thanks so much, Phil. It seems that there were no other questions coming in. And that means we still have a couple of minutes to spare before the next presentation. So there will be a 10-minute break.